In this video, we'll talk about our second information security control. The first, of course, being authentication, and we know that there's many ways of doing that. So once somebody authenticates, they're allowed into the entire system. Well, that's not necessarily the case. Now we're talking about not a human control, but a software and technology control, and that is firewalls. So what we'll do is we'll look at conceptually what firewalls are, the different types of firewalls, and then I'll run a quick demonstration to show you very simply how a firewall works. Okay, so let's talk about firewalls, Chapter 4. You can read this on your own. This is just an overview of what we'll be discussing. Some of these we'll go into in more detail, and I'll also have a demonstration to show you how a firewall works and how you set one up. And we'll take a quick look at that in Windows, and then we'll do something in Linux. So where does the name firewall come from? Well, there's a physical analog in the real world, and let me show you a quick conceptual demonstration here. Here we've got a house. Now notice that I'm not an architect, but I've shown you that we've got 3 bedrooms, we have a living room here, and we have a bathroom. So let's say that a fire, somebody's smoking in bed, of course no one smokes anymore, and it starts a fire. So there's a fire in bedroom 1. Well, what kind of security do we have to make sure that the fire doesn't spread to bedroom 2 and 3 and in the bathroom and in the living room? Well, we have none. All we have here is thin plasterboard walls or wood or something that can catch fire. So what we can do is, and you see this all the time now, is we add in between all of the rooms some type of material that retards or slows down or prevents the fire, once the fire starts, from going from bedroom 1 to any other rooms, because we have this flame retardant material or some type of structure in between the rooms that keeps this fire from moving from one room to the next. So we also have a technological analog here, and this is a very simple illustration because you can have firewalls in all different configurations, but what this is showing is you have the internet out here, you have computers that are connecting to the internet. In the space in between the internet and the computer is that you have something called a firewall, which can be hardware or software based. And so you can have a Cisco router that's got a firewall, a dedicated Cisco firewall that does nothing but that, or you have the firewall actually sitting on a computer. So notice what this is showing is you have packets coming in from the internet that are going through the firewall. You also have packets going out from the desktop computer through the firewall back out through the internet. So what we want to do is we want to let packets that we want to let in from the internet to the computer in, and we want certain packets to be let out. And we do so by creating something called firewall rules. And what firewall rules do is that they look at the contents of the packet, which would include particular information in the headers, and even sometimes, if you want to get very specific, even down to the payload, and compare the information in the headers against these rules in the firewall. If there's a rule in there that says, I would like to see allow all packets from, let's say, a particular IP address or a particular protocol, then that packet would be allowed in. If it's not allowed in, then there's several things we can do with it, and one of which is just to discard it and not allow it through, which essentially says this. So of course, there's going to be all sorts and manners of different types of packets, and we want to make sure that when we create our firewall rules that we create it in such a way that it allows in the packets that we want to, and we don't allow packets that we don't want to. So you can set it up by various criteria. I'll go over that in a moment. But also, look at this going out. Notice that this outgoing packets, these are called egress packets, are going from the computer through the firewall. Why would we want to do that? Well, there could be several reasons that we want to do that. For example, we may set it up so that you can't connect to a particular website, or you may set it up so that you can't connect to a particular series of IP addresses, so you limit it to only a certain set of IP addresses. You could also set it up like they've got here at Daytona State, so you can't even ping anything on the internet. So, and that's one of the examples we'll look at right here shortly, is you can set up a firewall rule in here that says do not allow any outgoing pings. The rule is no ICMP. So if it's an outgoing packet, if the packet is ICMP, which is used for a number of different network issues, but the one that we typically think of is ping, but ICMP is used for other reasons as well. In particular, there's something called an echo request, which goes over port 0, and that's called a ping. So if these three conditions match this rule, then it says drop the packet, don't let it out. And so simply, that's a very simple way to create a firewall rule. Let's look at another one. Let's say we have a rule for only allowing in FTP packets. So here's a very simple rule that's really not going to get us very far. It's a very general rule, and we'll see why we might want to add further conditions. So here's the if. The conditions are if it's an incoming packet and it's over port 21, which is FTP, then we're going to allow in the packet. But what if we have the condition that we have a number of different FTP servers sitting in on our internal network? Now, let's say that we want to allow internal users to access any of these FTP servers, but anyone coming from the outside must only use this IP address right here. So what kind of conditions can we add to that? Well, we can do this. So the conditions are now it's an incoming packet, the destination port is 21, which is FTP, and the destination IP address is this address. So if all three of these conditions match, then we allow them in to that address. So essentially that's a very quick and conceptual way to think about how firewall rules control packets incoming and outgoing to your network. So essentially, if you've read the book, that you know that firewalls filter packets. That's essentially what they do, and there's lots of different types of firewalls, but what we just saw in the previous demonstration was called a packet filtering firewall because it filters packets. We also have something called an application proxy, and we'll talk about that shortly. And so in the previous demonstrations I talked about what looked like a hardware firewall, but we also have software firewalls too. So if we have a hardware firewall, why would we need a software firewall that's sitting on, let's say, each of our individual desktops in our organization? Well, it just adds another layer of security. And so you think about it, if you go out in the cold wind and you've added a t-shirt, well, how do you get warmer? Well, you add an overshirt, then you may add a sweater, and then you may add an overcoat. And essentially what that does is it increases the chance that you won't get cold, just as increasing the probability that something awry won't happen on your network if you add more layers of defense to your network. And just to make sure we touch all the points here, sometimes they get a little, maybe exaggerate some of the things in the notes. As I said before, the packets monitor the entry and the exit points of the network. And this says they also scan for viruses. Well, it depends. You can have some firewalls that also serve as virus protection, but typically on a desktop, those are separate pieces of software. So you may have your software firewall, and separately you may have a virus scanner that will do what it says here, repair infected files. Just realize that every firewall doesn't scan for viruses. There's also another number of security features that some of the more advanced firewalls contain, including the ability to log. And this is really nice because essentially, remember when we talked about up here, we talked about these rules. Let's say right here. This is our firewall rule that only allows in packets that are going to a certain FTP server. We can also have a rule in here that says allow the packets, but also log the packet, which essentially says we're going to log every connection to this IP address. So it's nice, you can go back and look and see who has been logging into the system and where they've been logging in from. So it's a great way to audit your network connections. You can also set up a virtual private network, which is something we'll talk a little bit about later. And all this means is now you've got a virtual circuit in between your host computer and your server, and the contents of that are encrypted. You can set it up so that authentication occurs, is that they have to authenticate in some way, either password and username or some other token-based authentication process. We've already talked about shielding hosts inside the network. Caching data. Wow, they're really lumping a lot of things in here to firewalls. Caching data means that instead of going out, if you're requesting a particular website, that information has already been cached on the firewall because somebody else has accessed it, which means then rather than going out to, let's say, here, well, sorry, let's go up here. Is that you're requesting information from a website on the internet. So if a firewall caches data, that means that the firewall will look to see if it already has that information in its cache file, and if it does, then it will transmit that back to the computer rather than having you go out and connect to the internet across various routers and bringing that information back in. So it makes for a more efficient means of grabbing stuff off the internet. Okay, and here the authors kind of lump in various capabilities into a single firewall, but this isn't necessarily the case. We've already talked about packet filters. Proxy servers will go into a second. Authentication systems, you may or may not have that. Network address or port address translation, that's something that we use in VMware, and essentially that means that in the internal network, let me draw a quick figure of this. Well, before I do that, let's talk about bastion hosts. And a bastion host means that it's a hardened server that only contains the bare essentials running. So since it only contains, let's say, an FTP address, every other service is turned off, and it has it's an updated system. It's got all of its software updates to the most current, and therefore it's less likely to be the successful target of some type of attack. So let's look at network address translate. Network and port address translation essentially means that computers residing on a network that are sitting behind a firewall are going to share a common external IP address with the internet, and this gives you a conceptual idea of how that works. So we've got a firewall that's got a public IP address, 10.130.4.4, and sitting behind on the network we have network address translation going on, where the computers on the internal network have private IP addresses. So what do we know about private IP addresses? Well, we have Class A, Class B, and Class C private addresses. We know that those are not routable over the internet. So we can't have a computer on our network with a private IP address. Here, this is a Class C address that can directly access the internet, because the routers wouldn't know what to do with this return IP address, 100.1, 100.2, and 100. Incoming and outgoing packets with not only the IP address but also the requesting ports, as you see here. Notice that they're all different. And so any packets that once they leave the network will generate its own port number, its client-side number, which will be any port greater than 1024, and it will keep that mapping between that port and the IP address here. So once a request is made on the internet for, let's say a web address, those incoming packets will come back with the return address of 10.130.4.4, but how does it know where to send this? Well, it's got that mapping between whatever this IP address is and the port that's been randomly selected by the firewall. So let's say up here let's give us 100.1 is mapped to port, and 100.2 is mapped to, and 100.3 is mapped to 62. Okay, so I just randomly chose some numbers in here. Notice that all of them are greater than 1024 but less than 65,000. When a computer goes out and accesses a internet site, that return address is going to be, let's say computer, this first one right here is accessing Google, and so Google servers come back and says, obviously this goes to the firewall. This client side port is selected by the firewall, and so the packet that goes out is going to have this IP address and this port number. So when Google returns the results, it's going to send it back to this IP address and this port number. Well, the firewall knows that this port number is mapped to this computer. And the significance of this is that no one on the internet can directly connect back to these computers, right? Because these are private IP addresses. Try that sometime. Try to connect to a private IP address. Those are non-routable numbers, which essentially means that everything sitting back here on the network remains hidden behind the network address translation. So that's a quick and dirty explanation of how network address translation works. If you've got a router at home, little hardware router, and it's connected to a cable modem or something of that nature, you can see by going to what'smyipaddress.com, and it will tell you what your IP address is, and it's going to be something that's in the public domain. And however, if you look at the IP address of your own computer, it's going to be a private IP address because you have network address translation going on in that router. And this is a good example that shows you how you can have varying layers of protection for your internal computers. Notice here we have our private network. Those would have private IP addresses. And over here we have the internet. Notice here that sitting out on something called a demilitarized zone. And what that means is that these are computers that are accessible by people in both the private network and on the internet, and typically anything sitting in the DMZ will be a single use server. So you have a mail server, that's all it's going to do, and it's hardened against attacks. It doesn't have any other services running. You also have a web server. So you see that people from the private network can gain access to the mail server and the web server, but also people on the internet, let's say people working from home, can also access this as well. Notice in between these, in between the private network, the DMZ, you have a packet filtering router. Notice also over here in between the DMZ and the internet, you also have another firewall. So what these are doing is applying the rules against the incoming packet conditions to determine who can access the mail server and the web server from the internet, as well as who can access these things from the internal network. Are these rules going to be the same on the packet filtering router and the firewall? Probably not. There are going to be quite a few differences between them. So what kind of security controls do firewalls provide? Well, they can restrict access from outside the network, but they can also do the same for packets coming from the inside to the outside. They can restrict unauthorized access. They can limit employee access to external hosts. If you work in any type of organization, you may see that certain protocols are not allowed, or certain websites are not allowed to be visited. For example, on the Daytona State Network, we cannot use the torrent. Any torrent networks, is that those are automatically disallowed on our network, and that's done through firewall is used to protect critical resources. As you can see, is that you can set it up so only certain IP addresses are allowed to visit certain critical resources in your organization, and you can do that through several means, one of which is IP-based, that is only allowing certain IP addresses from the internal network to access other resources in the network, but also on an authentication basis. So you can combine the IP address as well as authentication, and what are you doing? You're doubling up on your security. You can also protect against hacking. Okay, I skipped a couple of slides, but they're pretty self-explanatory. But this is something I wanted to explain because I'm not sure if you've seen this before. And it's an important distinction between something called a stateless packet filtering firewall and a stateful packet filtering firewall. And essentially, the difference between these is that a stateless is a dumb packet filter. It doesn't remember any of the connections incoming or outgoing. So each time a packet comes in, it will be compared against all the firewall rules, and whichever firewall rule is the first to be matched, then that firewall rule will be, let's say, instantiated. So, well, a stateful packet filtering firewall will look at the contents of the packet, and once it matches a firewall rule, it will remember the state of that. So each time you have a new connection out, and as you know with HTML, it's not just a single packet that goes out, it's multiple packets. And that's essentially true with any protocol, is that once that matches, it remembers that state of either allowing it or disallowing it, and it puts that information in a state table. So it's kept in memory. And so what that does is each subsequent firewall rules that match that rule, before it goes through all the firewall, before that packet is compared against all the firewall rules, the firewall will look up that information in a state table. If it's already there, then it will apply the rule as it stands. So essentially, a stateful packet filtering firewall is much more efficient than a stateless packet filtering firewall. You can extend the basic packet filtering firewall to something called an application layer gateway, and this works at the application layer. If we jump back up here, and this is something that should be all review here, is that we know that in the OSI model, that the physical layer is at the bottom and the application layer is at the top. And so application gateways work at layer 5, 6, or 7, or if you're talking about the TCP/IP model, it's just the application layer, because all of 5, 6, or 7 are included in the top layer of the TCP/IP model. But also notice that you can set up firewalls that work at the MAC layer, that is the physical address layer, your MAC address, via packet filtering, so now we're talking about IP address, or at the transport layer, so now we're talking about TCP and UDP. Jumping back to the application gateway. So now, rather than working at a very low level, we're looking at the very highest level, the application layer. And the benefit of this is it minimizes the effects of viruses and worms and trojans and all other sorts of malware, because it's only working at a particular layer for a particular service, application service. And I skipped a few more slides because that's stuff that's very easy to read and understand. But let's talk about the different architectures, because there are several architectures that going from the very simple to the complex, and what type of architecture you use will depend upon what you're trying to protect. And so there's most of what you see are just simple packet filtering routers. You know, the single operator, home operator little routers that you have just do simple packet filtering. And you have something called a screened host firewall, which combines the packet filtering router with a dedicated firewall, such as an application proxy. And let's take a look at this right here. Let's make this bigger so you can see it. And so essentially what we have over here, and you see the words trusted network, and that usually means that's the internal network, that's your organization's network. Out here we have the untrusted network. That's going to be anything you don't trust, but usually that's deemed the internet. Notice that we have the application firewall here, and off to the side here is that we have a bastion host, which is a hardened server. And notice that the firewall here serves at the application level, and so elements on the trusted network are allowed proxy access, which would just be over the application layer, to applications on the bastion host. Notice that the single firewall here is blocking data packs coming from the untrusted network, and anything that's let in is going to be filtered through the firewall rules at the application layer. Then we have something called a dual-homed host, and it's called dual-home because it's a single bastion host that contains two network interface cards rather than one. And then you have a firewall sitting on the dual-homed host. And one of the NICs is connected to the external network, and obviously the other one is connected to the internal network. Let's see what that looks like. Let's make this bigger. So it's much like what you saw before, only now we're adding two network interface cards to the dual home host here, and I'm not sure why they're using different icons now to represent the bastion host, but this is going to have a network interface card that's going to the untrusted network, and then you have another that's going to the internal network. And you also have something called a screened subnet firewall, a screened subnet, and this usually includes a demilitarized zone where you keep all of your single-purpose servers, such as a web server or a mail server or an FTP server. And this is the dominant architecture that's used today because it uses two or more bastion hosts behind a packet filtering router, and it's one that we saw previously up above. Let's take a look at that architecture right here. And here you have your demilitarized zone servers that are sitting in between two packet filters. Sitting in between two packet filtering routers. And so each of these is typically a bastion host. It's a single purpose server that's been hardened. And notice that the trusted network entities can access this through the internal filtering router, which can be a packet filter, and the untrusted network must also go through its own external filtering router to access this. And once again, what you see in here, these packet filters are going to have probably entirely different firewall rules matching, because that makes a lot of sense. You're going to have different IP addresses. You're going to be allowing certain people in here to the trusted network, to the demilitarized zone, and you're probably going to be allowing fewer public IP addresses in here to access those servers. Limitations of firewalls. Well, they can't be expected to do everything. Probably the biggest drawback of firewall rules is that you need to make sure you get the firewall rules right, and there's two possibilities of getting the firewall rules wrong. One is you're letting in packets that you shouldn't be, and the second thing is causing yourself a denial of service attack. And I've actually done this to myself. Is you set up a firewall rule and then all of a sudden you can't get to a server. Well, why? Well, because you accidentally added an improper condition to your firewall rule, or you forgot something, for example, to allow yourself in. And so before you put up a firewall, you should check all the rules and to make sure that they are correctly written. So now let's run over to the demonstration and see how packet filtering is done in Linux. Okay, so I have two virtual machines running. I've got here I've got Mint 12 running, and over here I've got Ubuntu server running. And let's see what IP addresses these are to make sure they're on the same network. Notice that VMware uses network address translation, right? Because this is a private IP address, but I can get out on the internet. So that's .49, .132, Let's go back to Mint and make sure it's on the same network. .49.134, so 134 and 132. Okay, the Linux kernel has a firewall built into the kernel, and it's called Netfilter. We can't access that directly, but what we can do is to access it through a mechanism called iptables. And essentially iptables is a syntax that allows us to add and subtract various types of rules to the firewall in Linux. And so the simple way to see what firewall rules are currently available is, I said this was at the kernel, right? So we're going to need to type sudo, and then we type iptables -L, which means list those bad boys. And it tells us several things, one of which is that we have various, they're called chains. And remember I talked about incoming and outgoing? Well, notice here we have something called an input. That means this, anything below this would be firewall rules for packets incoming into this computer. We also have one called output, and that is packets going out of the firewall from this computer. But notice outside of these labels here, there's nothing listed, which means there's essentially no firewall rules on here. Notice also that it says it has a policy. A policy is a default firewall rule that matches anything if no other rule matches. So what this is saying is that for any incoming packets, if it doesn't match any firewall rules, then accept that a packet, that is, allow that into the network. The output says if there's no firewall rule that matches any of the outgoing packet rules, then allow that to go outside the network. And then we have a third chain in here that we're not going to go over, but essentially the forward means forward that from one network interface card to another. So I don't have two network interface cards in here, but we could easily do that in a virtual environment, but we'll just keep it simple for now. So what we're going to do is we're going to create a firewall rule that stops incoming ICMP packets. So let's hop back over here. Well, first thing we need to do is we need to start Wireshark, and then we need to start capturing packets. And so we're going to type sudo Wireshark. Okay, and we have ETH0 right here. And notice that we've already got some packets going on. Notice my Dropbox right here. But let's go back over here and let's ping 192.168.49.134. Let's see if we get a response. We're getting a response, right? That means Mint is responding. Let's go back over here. Ah, here we go. Okay, so notice starting in packet 4, 132 I said was the server, right? So notice that the source is the server, the destination is Mint. The protocol is ICMP, and the ICMP type is an echo request. Recall that I talked about that previously. Well, in Wireshark it's nice enough to tell us that an echo request is part of a ping packet, right? Okay, let's look at the next packet 5. Notice now the source is 134. That's our Mint. The destination is 132. So this was an incoming request, echo request. This is what? ICMP, echo, reply. And so we have, if we were to start creating a firewall rule for this that is not allowing in these echo requests, then this would be on the input chain, correct? And this would be on the what? Output chain, because this is coming out of our source, which is Mint, which is what we're in right now. Okay, so let's go in. Let's stop that. And let's open up another terminal. Just open up a tab. And let's create some firewall rules. And actually I'm going to be changing things here midstream and making it actually a little simpler than what I was going to, because in a later class we'll talk about iptables. But there's even a simpler way to do that, and that's using this simpler interface called the Uncomplicated Firewall, or UFW. And essentially what that does is that communicates with iptables, which is the syntax that is used to connect with the kernel firewall Netfilter in order to define your firewall rules. So just before we get started, let's see what ports we have, because what we'll do is I can actually make this a little more complicated example because we're using the uncomplicated firewall syntax. So let's look and see what we've got running. Oops. Okay, so we really don't have a lot running here, so what we'll do is I'm going to pause the video and I'm going to add telnet, FTP, and SSH, and then we'll start back up and we'll create some rules for that, okay? Okay, it's been about 2 minutes and I've installed telnet, FTP, and SSH. Try to do that on Windows and see how long that takes. I kid, but it's true. Okay, let's go back and run netstat again. Let's see what we've got available. Alright, so we've got 21, which is FTP, we've got 22, which is SSH, and we've got 23, which is telnet. Alright, so now we can create some rules that allows or disallows the server from connecting. So the first thing we want to do is to type sudo UFW enable. And what that's going to do is going to enable our firewall. It gives us a nice little message here. You know, because this is an uncomplicated firewall, maybe we want a little feedback, because usually when something occurs in Linux and it does it without an error code, it doesn't say anything, right? But here it gives us a nice little thing that says the firewall is active. But you know what? We still don't have any rules. And if you want to know more, if you'd like to know more about the switches and whatever, you can always type man UFW for the man page, and you can scroll down and take a look at all the different features that it has. Notice that it supports logging right here, which is nice if we want to do that. It allows us to check the status. Notice this allow means we're going to allow something to come into the network or to leave the network. Deny means that we're just going to drop it. And reject is a little different. We're not going to get into that now, but it kind of acts like deny. Deny, but reject will send back a packet to the requesting host. You can also delete and insert rules. Okay, so let's get out of that, and first let's go in and let's go back to our server and let's see if we can log in. So let's log in to telnet. And I just learned something. I'd stop the video, for example. Let me go back in here. Notice here I said disable. The reason was I just learned something, because usually I don't use the uncomplicated firewall. I use iptables, which is more complicated, but at least it's more explicit about what you're doing. So let me go back and enable the firewall, and now let me go back up and attempt to telnet in. And guess what? It won't allow me in. And, and the reason is, apparently the default policy is to deny. So let's get out of there, because if I go back in and I disable the uncomplicated firewall, let's go back over here to server. Let's telnet in. It's giving me something back. It's negotiating, and I'm logging in as PC and my usual password, and I'm into Mint. Okay, so good to know. So let's go back up here, and we're going to re-enable the firewall, and let's check on the status of the firewall. So we can check the status of the firewall. Is it active? And so let's go ahead and explicitly set a default policy. What would be the best default policy? Would it be to allow all packets or to deny? Well, in most cases, the best default policy is going to be to deny packets, because you're always going to miss something. And so I won't say you're always going to, but it's quite often the case that you might miss something. And so the flip side of that is that you could cause yourself a denial of service attack. In essence, that is that you're not allowing in a user that should be allowed in. So what we're going to do is we're going to set this to default equals deny. And so the default is to deny, and we can go back over and check that in server by trying to SSH into it. 134.49.134. It doesn't allow us in, so let's go back. Stop that with Control C. Let's go back to Mint, and let's add a firewall rule that allows an SSH connection from that IP address alone. So we want to type sudo allow 22 TCP to allow from 192.168.49.134 port 22. So let's allow anybody to connect to SSH. Remember, our default policy is deny, so we're overriding the default policy by allowing in connections to port 22. So UFW allow 22, and then we can go back and we can check the status of UFW and see if we've got any rules there. And it actually added two rules, one for IPv version 4, which is the top one, and then version 6, the bottom. Does that by default. Now let's see if this works. And if you see before, it did not work. Whoops. And hey, it's working. And we're back in. So we've connected to Mint, but let's see if 8.49.134, and it's still denying us. What about Telnet? Telnet 192.168.49.134. It's trying it, and it won't let us. So let's go back over here and let's open up port 23, sudo UFW allow 23. Let's go back and look at our status. Now notice that we've got our 4 rules, 2 of which are for IPv6. And that was Telnet. Let's see if that works. And we're in. So that was a very simple illustration of how firewalls work. What you should take away from this is that firewalls can be either a hardware or a software solution for filtering packets, for controlling access to various resources. You can have more than one firewall on a network, and all it does is adds layer and depth, and each of those firewalls may have different configurations, that is, different sets of rules that can be used in order to allow access to various company resources, and those rules will depend upon whether your source is coming from the trusted network or an untrusted network such as the internet.